Okay, so at the top of this page, there's a box that says first thinking. So even though you're watching a video, I think it would be useful. So if you would just pause the video and kind of see if you can answer the two questions in that first box, and then unpause the video and we will talk about it. Okay, so what you should notice here is two separate equations, and what we wanted you to look at is what the thing was that made them different. And this first equation here is a quadratic. So it's got a x and a squared, whereas the other one has a 2 to the x. So I would say, like, if we call this equation number 1 and this equation number 2, equation number 2, whoops, not have, has a variable in the exponent, whereas equation number 1 does not. So it's a very big difference in where the x is. So in equation number 2, the x is in the exponent. In equation number 1, the x is the base of the exponent, and those get solved very differently. So the next question was, can you solve the first equation, x squared equals 9? Well, we can solve that by just square rooting both sides. That we learned back in unit 2. So the answer would be plus or minus 3. Okay, so you can imagine that our next task is going to be, well, how do we solve the second equation then? Since it isn't the same, so I can't take a root because I don't know what the exponent is. So the question is, how would I do it? So that is first thinking box 2. So same idea, if you just pause the video and give number 1, 2, and 3 a try, and then try answering this question right here about how they're different, and then unpause the video. Okay, so questions 1 and 2 can be solved just by either, sometimes you can just tell by looking, but if not, by getting like bases. So number 1, if I get them both to have bases of 2, I would have 2 to the x equals 4, and that would be 2 to the x equals 2 squared, and therefore x has to equal 2. On the second one here, I could rewrite those both to also have bases of 2. So 4 to the x would become 2 to the 2x, and 8 would become 2 cubed. And so then these two exponents have to be equal. 2x has to equal 3, and so x has to equal 3 halves. What happens on number 3 is that you can't get like bases. So 2 and 9 are not powers of the same number. So, I mean, maybe I could write 9 as 3 squared, but I can't set those exponents equal to each other because they don't have the same base. Okay, so 1 and 2 are different because you are able to get like bases. So number 1 and number 2 can get like bases, whereas number 3 cannot. And so that is what we're going to learn today, is what do we do when we can't get like bases. So let's take this number 3 and let me show you. What you should know by now is how to convert from one form to another. So this is exponential form, and I can convert that to log form, and it would say log base 2 of 9 equals the x. So how we get an x out of the exponent is by using logs. And so we take this from exponential form and we write it in logarithmic form, and then we use our calculator because it isn't going to come out to a nice whole number because they don't have like bases. So log base 2 of 9 equals x. Now I'm going to type that into my calculator. So kind of go over here to the left side of the video, and I'm going to show you the two different ways to enter that into your calculator. First way is you press math, and then I'm going to use the up arrow because I'm trying to get to A. Whoops. Let's go back, math. Trying to get to this where it says log base, and I'm going to choose enter. And my calculator is going to let me put a 2 for the base and a 9 inside, and then press enter. So what I would get here is that x equals 3.1699. Okay? If your calculator does not have those buttons, then you have to use what we call the change of base formula, which we learned a week or so ago. But that looks like this. You're going to type the log of 9, close the parentheses, divided by the log of 2, close the parentheses, and then you should get the exact same answer. And we'll go through those buttons again and again as we go through this video so you can get some practice on that. Okay? Okay, so let's look at number 4 here. The question says 4 to the x equals 20, so you should first always look to see if you think you can get like bases, but in this case I cannot. So we're going to take it from what is exponential form, right? This is exponential form, and I'm going to just put it in log form. This would be log base 4 of 20 equals my exponent. And once you get to here, it's all on your calculator, okay? So you're either going to use the fancy button. I'm going to go through those button pushes again. Math. And then you're looking for A that says log base. And I'm going to put a 4 for my base and a 20 inside. Or, and I'm going to just write this, or you're going to take the log of 20 divided by the log of 4. So on my calculator, I'm going to take the log of 20 divided by the log of 4, and that is what we call the change of base formula. And in this case, you would get 2.161 for your x value. Okay? Same idea for number 2. This is an exponential form, so I'm going to write it in log form. This would be log base e of 7 equals x. Okay? And then hopefully you know and recall that log base e of 7 is the same as the natural log of 7. So in this case, I can just type the natural log of 7, and I would just get 1.946 equals my x value. Okay, and let's try this last one here, and then I'm going to let you try a couple on your own. So it's currently in exponential form. My x is in the exponent. That's how I know I need a log, and I'm going to just write this in log form. So it'd be log base 5 of 17 equals x. And then again, math, go find A, and then you're just going to put a 5 as the base and a 17 in here, enter. Or if you don't have that button, the change of base says log of 17 divided by log of 5. So I'm going to do that so you can confirm. So log of 17 divided by log of 5 gives me the same decimal, which is 1.760. Okay, so now there's a you try section here. So if you would pause the video and try 4, 5, and 6, then you can see how you did when you get back. Okay, so here in light blue are the answers to those 3 questions for you to check. I also have a little bit of my work, so if you have any troubles, you can try to look through my work. Okay, so this last section is kind of about choosing. So what I'd like you to do first is just look at those 6 problems at the bottom and take a minute and just circle 3 of the 6 that you think you could solve by getting like bases, where you wouldn't have to use logarithms, but instead you could use like bases. So pause the video, select your 3, and then unpause it and see what the answers are. Okay, so 7, 9, and 12 can all be solved by getting like bases, so I don't need to use logs, although I could if I had a calculator, but if I don't need to. So number 7, I'm going to write this as 3 to the x, and 1/9 would be 3 to the negative 2, and so I would get x equals negative 2. Same thing over here, number 9. 16 and 8 are both powers of 2. So 16 is 2 to the 4th. So this would say 2 to the 4x. And 8 is 2 to the 3rd. So 2 to the 4x equals 2 to the 3rd. So then I set 4x equal to 3. And I would get x equals 3/4. And then same thing down here, number 12. 25 is 5 squared. 1/25 is 5 to the negative 3. So then I would set my exponents equal to each other and divide by 2, and I would get x equals negative 3/2. Okay? The remaining 3 cannot be solved by like bases, right? So number 8 here, 3 and then 3/5, I can't get like bases. So that, in order to solve for the exponent, means I need to convert to log form. So it'd be log base 3 of 3/5 would equal the exponent. And then I'm just going to go to my calculator and choose my log base 3. 3/5, you use the division sign to enter. And so you get negative 0.465 equals x. Okay, same thing on 10. 8 and 12 are not powers of the same number. So in order to solve for that exponent, I'm going to have log base 8 of 12 equals my exponent. And then I'm going to go back to my log button. Oops, I keep pushing something weird that gets me out of there. Okay, there's my log button. 8 base 8 of 12 equals, so I get 1.195. And then this last one, this would be log base 25 of 10 equals my exponent. And so I'm going to just go find my log button. It's going to be 25 and 10. And so I get 0.715 equals x. Okay, and then just for fun here, let's take number 7. Let's say you had a calculator and you did not recognize that you could get like bases. You can solve that with logs also. It would be log base 3 of 1/9 equals the exponent. And if we go to our log button and type in a base of 3 and a fraction of 1/9, we should still get -2. Same thing we got by getting like bases. So assuming you have your calculator, either method is actually fine. I just think usually it's a little more efficient to get like bases, plus part of your test you won't have a calculator, so that wouldn't be an option.